Hi and welcome back to this Intro to Machine Learning course from Pinata. Today we're going to learn about basic classifiers. In this video we're going to cover what do classifiers do and how they work. We're going to focus on the k-nearest neighbours algorithm and learn how it works and how to fit it in Python. And then at the end there's going to be a small exercise where you get to try this out for yourself. Let's get started. What do classifiers do? What problems are they attempting to solve? We covered this in our first video, but a quick review. We're focusing on classification problems, and a classification attempts to predict a label from two or more discrete classes. It finds a decision boundary to separate the classes. We're not thinking about regression that attempts to predict a continuous outcome. Classification algorithms work by splitting the problem space into areas that are assigned a class. We can think about the decision boundary as the dividing line between one prediction area and another, the separation between classes. This isn't always clear. If we have high-dimensional data with a lot of interdependencies and relationships, it's going to be a lot harder to see compared to a simple binary classification problem with just one variable. When we build a classifier, the goal is to find the best estimate of the decision boundary. We can see an example of this with our iris dataset. We have three classes, coloured here blue, orange and green. The coloured regions represent the prediction area, and the line between them is the decision boundary between class 0, class 1 and class 2. At a glance, this model seems to be quite good, but we'll go into that in more detail later. Now we have the basics of classification problems down, let's learn about the algorithm that we're going to use in this course, k-nearest neighbours. K-nearest neighbours tries to classify our data by comparing each point to the points around it. It has a hyperparameter k, which refers to the number of nearest neighbours. In the example on the right, we can see how the algorithm would work for the red cross based on the classifications of the points around it. We have two classes, the blue crosses on the left and the green crosses on the right. If k equals 5, we're using 5 nearest neighbours to classify the red object. This is shown with the purple circle. This gives us 3 blue crosses and 2 green crosses. If we used k equals 5, this would then classify our unknown object, the red cross, as a blue. However, if we chose k equals to 3, the 3 nearest objects to our red cross k are 2 green crosses and 1 blue cross. At this point, our unknown object would be classified as green by the model. In practice, we would run through a range of different values for k, compare the outputs and success metrics, and use that to choose the value for our final model. An important term in machine learning modeling is a hyperparameter. A hyperparameter is a parameter whose value is set before the learning process begins. In the modeling process, we want to optimize these to help us find the best fit model. We typically do this by running lots of iterations with different values of the hyperparameter. We want to start with a good best guess and then improve on that. Some algorithms have more hyperparameters than others. Fitting a basic KNN classifier in Python is very simple. We're using the sklearn library. sklearn is a great library full of different classification, regression and clustering methods. Here, we're only importing the neighbours classifier. We're not importing the methods that we don't need to use. We initialize our model, called model, as a k-neighbours classifier, and here we set our nearest neighbours to equal 6. The two parameters here in the fit method are x and y. X is our input data and y is our label. In this case, x would be such variables as petal width and petal length, and y is the species of the flower. 3 lines of code, classifier built. Now it's time for you to have a go yourself. We provided a link to a notebook containing a bit of setup code, giving you the chance to train a model on some data. See how you get on, and maybe even try some different classifiers. But next time, we're going to learn about how to check the accuracy of a classifier and assess the performance, and we're going to also cover how we can prevent our model overfitting the data. Then to top that off, there'll be another knowledge check, little practical part for you to do. If you have any questions, leave them in the comments. And as always, this is a great chance for you to go and experiment, try things out for yourself, do a bit of extra reading, Google is your friend. So when you come back next time, you'll be in a great position to move to the next topic. See you then.